power, it's more concentrated because of a smaller internal diameter, smaller surface area. The main thing with the fine end that I enjoy using it for is procedures like this when you're performing a delicate skin peel, because you have a lot more precision with the tip of the sucker being narrower. And this skin is quite thick, and I'm just really leveraging it up. Okay, it's quite a thick blanket, it's really strongly adhered, and I was having to really work at the skin. Sometimes skin peels away so easily, sometimes you have to put a bit more force behind it. This is that isthmus which I mentioned in patient 1. You can see the ear canal narrows, then it widens again, so the skin is slightly lodged there. I think I managed to peel it away, we shall see. You can sometimes use a bit of oil as well to soften the skin. This patient was wearing hearing aids upon attending, so I was going to avoid using the oil wherever possible, because as soon as they put the hearing aid in, it can get really oily and greasy, and it can block the hearing aid. And you can see we managed to remove that without any oil. This is the same patient. This is their right ear. So again, a lot of dead skin as opposed to earwax. Now, earwax is actually made up of dead skin. Typically around 60% of earwax is made up of dead skin. Now, you can get dry earwax, and dry earwax simply has a high concentration of dead skin, dead keratin. There's typically 2 types of wax. You can get wet type of wax and you can get a dry type of wax. The type of wax you have is not completely regulated by genetics, but genetics has a big factor. There's a particular gene called the ABCC11 gene, and that gene is responsible for the transportation of certain molecules across cell membranes, and also within a cell, membranes within a cell, so intracellular membranes. And more specifically, it helps to transport odorous molecules within the ceruminous glands. The ceruminous glands are a particular gland that are found in our ears and also inside the groin and under your armpits. I'll come back to that in a moment. So you can see I've cleared that ear. There's just a flock of hairs. I'm just going to remove that with a fine end. And a functional ABCC11 gene has at least one dominant guanine allele. So if you're into your DNA and your different nucleotides, so it has a dominant guanine allele. But there is a mutation to that gene, and that's where you have 2 recessive adenine alleles. So 2 homozygous adenine alleles. And if you have that specific gene mutation, it actually renders that ABCC11 gene as redundant. It stops its function. So it doesn't transport these certain molecules, that odorous molecules, within the ceruminous glands. And so imagine you do have a functioning ABCC11 gene. It transports these molecules which then form and combine odorous molecules, either without interference in the bacterium. Now, sometimes these molecules, when they are secreted by the ceruminous glands and they reach the surface, they then interact with the bacteria, the skin flora. And once the bacteria feed on these secretions, then it lets off an odor. And so if you've got a functioning ABC